Hello everyone, welcome back to Mathematics for Everyone. In this video, we shall take questions relating to expansion of determinant by using the properties of determinants. Let us take first question. Prove that determinant ABC a square b square c square then BC CA AB is equal to A minus B B minus C, C minus A into AB plus BC plus CA. Proof. Left hand side, determinant ABC, A square B square C square, BC CA AB. Then operating on C1 multiply C1 by A, C2 by B, C3 by C. So left hand side becomes because we are multiplying these three columns by ABC, you will have to divide at the same time. First column becomes A square A cube ABC. Second becomes B square B cube ABC. Third becomes C square C cube ABC. Taking ABC common from row R3. So we get ABC over ABC, determinant A square B square C square, A cube B cube C cube, 1 1 1. Then operating on C2 minus C1 and on C3 minus C1. So left hand side becomes, first column is A square A cube 1. Second becomes B square minus A square B cube minus A cube 0. Third becomes C square minus A square, then C cube minus A cube 0. Then we taking common B minus A from column C2 and C minus A from column C3. So left hand side becomes B minus A into C minus A. Determinant first column is A square A cube 1. Second is B plus A B square plus A square plus AB 0. Third column is C plus A C square plus A square plus CA 0. Then operating C2 minus C3. Operating on C2 minus C3. So we get B minus A, C minus A, first column, A square AQ1, B minus A, B plus A minus C minus A becomes B minus C. B square plus A square plus AB minus C square minus A square minus CA. So we are left with B square plus AB minus C square minus CA, 0. Third is same, C plus A, C square plus A square plus CA, 0 is equal to B minus A into C minus A. First column is A square A cube 1. Second is B minus C. Then B square minus C square plus A into B minus C. Then 0. Third is C plus A, C square plus A square plus CA, 0. Then we take B minus C common from C2, taking common B minus C from column C2. So we have left hand side becomes B minus A into C minus A into B minus C. We are left with first column is A square AQ1. Second is B minus, 1. B minus C is common 1. Then here is B plus C plus A, 0. Last is same, C square plus A square plus CA, 0. Then expanding by third row, expanding by row R3, we get B minus A into C minus A into B minus C. We are expanding by third row, 1 into C square plus A square plus CA is C square plus A square plus CA minus. We are multiplying C plus A into B plus C minus A. So we are left with minus BC minus C square minus CA, then minus AB minus AC minus A square, minus 0 plus 0 is equal to B minus C into B minus A into C minus A into B minus C. Simplify this. A square cancelled, this AC cancelled, C square cancelled, and we are left with minus BC minus CA minus AB. Taking minus common from this, B minus A becomes A minus B. A minus B into B minus C into C minus A into AB plus BC plus CA, which is equal to right hand side, hence proved. Then we are taking second question. Question 2. if x is not equal to y is not equal to z, and determinant first column x squared 1 plus x cube, then y squared 1 plus y cube, z square 1 plus z cube is equal to 0, then prove that xyz is equal to minus 1. Prove we have determinant x square 1 plus x cube, y square 1 plus y cube, z square 1 plus z cube. We know that we have a property if the elements of any row or column are expressed as a sum of two terms, then the determinant can be expressed as the sum of two terms. Now because C3 column consists of terms in which there are sum of two terms, so we shall separate it as sum of two determinants. So this implies first is x square 1, y square 1, z square 1 plus second determinant x square x cube, y square y cube, z square z cube is equal to 0. Then we shall take, in the second determinant, you will take x common from first row, y common from second row, z common from third row. Taking common x from row R1, y from row R2, z from row R3. In second determinant, so we get first determinant as it is, x square 1, y square 1, z square 1. In the third, we take x common from R1, y from R2, z from R3, x, y, z. So we are left with 1x squared, 1y squared, 1z square is equal to 0. Then interchanging C2 and C3 in first determinant, we get x, y, z, 1, 1, 1. Third column is x square, y square, z square plus x, y, z into first column 1, 1, 1. Second x, y, z. Third is x square, y square, z square is equal to 0. Then there will be negative sign. Why? Because we have changed C2 and C3. Again, interchanging C1 and C2 in first determinant, we get, when you interchange again C1 and C2, again you shall take a negative sign, negative will become positive. So we get determinant 1, 1, 1. Second x, y, z. Third column is x square, y square, z square plus x, y, z into first row is 1x, x square, 1y, y square, 1z, z square. Now this determinant is common. So we take determinant 1x, x square, 1y, y square, 1z, z square into 1 plus x, y, z is equal to 0. Then we operating R2 is equal to R2 minus R1 and R3 is equal to R3 minus R1 in this determinant. So we get first row 1x, x square, 0, y minus x, y square minus x square, then 0, z minus x, z square minus x square into 1 plus x, y, z is equal to 0. Then taking common y minus x from second row and z minus x from third row. Common y minus x from second row R2 and z minus x from third row R3. So we get y minus x into z minus x determinant first row 1x, x square, second 0, 1y plus x, third 0, 1 z plus x into 1 plus x, y, z is equal to 0. Then expanding determinant by first row R1, we get y minus x into z minus x into 1 into z plus x is z plus x minus 1 into y minus y plus x minus y minus x into 1 plus x, y, z is equal to 0. So we have y minus x, z minus x into this z minus y into 1 plus x, y, z is equal to 0. Therefore, either y minus x is 0 or z minus x is 0 or z minus y is equal to 0 or 1 plus x, y, z is equal to 0. So this will give you y is equal to x, z is equal to x or z is equal to y or 1 plus x, y, z is equal to 0. But it's given that it is given that x is not equal to y is not equal to z, then 1 plus x, y, z is equal to 0, which implies x, y, z is equal to minus 1. Hence proved. So that's all. In the next video, we shall take more questions on expansion of determinants by using properties of determinants. So please don't forget to like, share, comment and subscribe to Mathematics for Everyone. Thank you. See you in the next video.